Okay, so thank you very much for inviting myself and Naval Health Research Center to present and talk at your webinar. Very excited to share some of the work that we're doing in our research in biomonitoring of warfighter performance, as well as how we are hoping to use the Hexoskin and Astroskin products integrated with some of our research. So my name, again, is Amy Silder. I have my PhD in biomedical engineering. And I work again here at Naval Health Research Center in the Warfighter Performance Department. So this is a map of where we're located. It's San Diego, and that's the farthest south and west that you can get in the United States. So we can see Mexico from Point Loma. On the map above, on the very top, is Coronado Island. If you've ever been to San Diego, it's an extremely popular tourist destination. And then what would be in the upper left is the downtown city of San Diego. And San Diego has a lot of different military installations and a lot of Navy ships to look at if you ever come visit. So before I continue, I want to acknowledge all of our funding sources that I'm going to mention in this presentation, and also make note that the opinions and statements that I make for the rest of the presentation are my own opinions, and they don't necessarily represent those of the United States government or any affiliate. So NHRC, Naval Health Research Center, is a military research command. We're not a training command, meaning our entire mission is to improve the health and well-being and performance of the United States military, our veterans, and translate that work into the civilian population. We have three main lines of research, which are divided into what are called directorates, and within the directorates are departments. So very similar to a university setup. The first is operational readiness, and that's where I work and my colleagues work. Most of my colleagues work. Within that, we have Warfighter Performance Department and the Medical Modeling and Simulation Department, which is epidemiology work, using large databases throughout the military health system. Next is military population health, and the picture describes that quite well. If you look at the United States military as a whole, how do you understand that? How do you improve that, optimize that through two departments, health and behavioral sciences, which is usually stateside, so here in the United States, as well as a little bit overseas. Those are who deployed overseas, and then deployment health in operational environment. And finally, operational infectious diseases. So we have an entire infectious disease department who does a lot of work on both stateside again and diseases overseas. And they work a lot in conjunction with some of the other infectious disease departments, as we do throughout the other branches of the military. So I'm going to focus primarily on warfighter performance and operational readiness, because that's the department that I'm in, and that has to do a lot with warfighter, individual warfighter monitoring using biometrics. So one of the labs in our department is the Sleep Tactical Efficiency and Endurance Lab, or STEEL. We have a lot of neat equipment that we use to monitor the warfighter, test them, put them in different situations. So this lab utilizes sleep rooms within our building, and they're equipped with telecoms, infrared cameras. The participants wear various monitoring equipment. You can see in the background of one of these pictures, I believe these might be the Hexoskin shirts. Sound attenuating cognitive performance testing rooms, which are in the upper right. So those are sound chambers. And then driving simulators of three things that we use a lot, as well as monitoring devices out in the field. So various wearable sensors to monitor sleep, activity level, things like that. So for example, with this slide, a participant might, one of the research studies, they sleep overnight. We monitor their sleep. We wake them up in the middle of the night, have them do cognitive tests in these sound attenuating rooms, have them perform a driving simulation. Some of them would perform shooting simulations, some of them, and then we put them through different situations to help them wake up or help them fall asleep and measure their performance. And you can see the participant in the lower right has EEG sensors on him. We also have a lot of different equipment to measure functional movement and body composition. So a biodex dynamometer, as you can see in the upper left, a protokinetics instrumented walkway, which is based on the east coast of the United States. Instead of a pressure insoles, which are very common, this is a mat that has pressure squares throughout the entire length of the mat, and we get spatiotemporal measurements from this as continuous walking. We have a DEXA scanner, so body composition and bone density. We use that both for diagnostics in some of the special operations forces, as well as to understand how body mass distribution might affect someone's physiology, biomechanics, and overall performance. Additionally, we have a bunch of support plates for jumping, for balance, some functional movement screen and wide balance test devices, as well as the Neurocom and some other portable static and dynamic balance tracking devices. And we use all of these things we have, should count it, a large number of studies going on between 4 or 5 labs within this that share this building space, and we all work together through biomechanics, sleep, nutrition, environmental physiology, and regular performance physiology. So shown here is an example or a picture of a participant walking on our Karen device, which is a virtual reality system that we use for a large number of studies. This is part of the lab that I'm a part of, the Physical and Cognitive Operational Research Environment, or PHI-CORE lab. Our motto is testing of physical and cognitive performance utilizing operational objective measurements in laboratory and field environments. So to summarize, as it says, we look at the combination or the integration of physical and cognitive performance in warfighters, and how does that impact their physiology, and then integrating, again, sleep and nutrition into their physical and cognitive performance. So this participant here who's walking through a virtual environment, and he is asked to shoot at various targets. We're measuring in this situation trip. We measured his accuracy, his timing, and for example, he could be asked to do this in the middle of the night when he wakes up from sleeping. People after traumatic brain injury, and different situations we can change in this environment. So as I said, our lines of research are quite broad. We do clinical and operational research. So some of our clinical research involves fall prevention in persons with an amputation, orthopedic injuries, anywhere from tendinopathies, ligaments, surgeries. We work with the orthopedic surgeon in the area, and we have multiple physical therapists and athletic trainers on staff as well. Vestibular physical therapy, this is a large line of research that we have using the Karen system, again shown here, as well as transferring or demonstrating portable systems, so augmented reality and virtual reality, and again, monitoring physiological health or physiological response, both on the Karen and then in portable systems. Traumatic brain injury, again, very similar to vestibular rehabilitation, and some therapies to address and measure post-traumatic stress, so improve outcomes in people that have PTSD. Our operational research is also quite broad. A lot of this happens out in the field at the various training commands around San Diego. We evaluate personal protective equipment, body armor, helmet, backpack. We measure human interaction and performance with the PPE. So, for example, right now we're looking at how does wearing a hip belt versus not wearing a hip belt when walking with extremely heavy loads, how does that affect spinal forces and shear forces in the spine? Load carriage, fatigue medication, which is a very collaborative effort, and sometimes the effectiveness of simulated training. So that was similar to the service member who's walking on the Karen and doing shooting scenarios in a simulated environment, which both saves time and money, and it allows us to measure. Again, it's all about measuring and improving warfighter performance and rehabilitation using various monitoring systems. A little bit more about the Karen is that it can be used for a wide number of things. Like I said, it has optical motion capture, which is where our motion capture system is located in this environment. They can walk with or without this virtual environment. 180-degree curved screen, motion platform. So this is a MOTEC instrumented treadmill. So 6 degrees of freedom, unlike just incline and decline from a lot of the other treadmills. Changing surfaces, it can vibrate. Like I said, the split belt force instrumented treadmill, a programmable sense system, which has been used to, it's quite accurate or quite believable, simulate post-traumatic stress. And there's some very pleasant and very unpleasant sense there. And again, going back to the biomonitoring theme, you can very clearly measure someone's stress reaction, or whether that be good or bad, with different environments, including sense. An integrated laser shooting simulator, which we have here, as well as in the thermal chamber, which I'll show soon. And mobile, augmented, and virtual reality systems. We have a variety of different types. So the environmental physiology lab, which I just mentioned, is one of few in the U.S. It is very large. It has 20 feet wide and 29 feet long. The temperatures in there can range between -20 and 120 degrees Fahrenheit. We can change the humidity, cause wind, and change the radiant heat settings. So you can see a participant walking on our treadmill. We have 4 large treadmills in there. They're oversized treadmills, so we can have up to 8 people walking or running. It's a little dangerous if there's 8 people running on those treadmills at the same time. The participant here is wearing a mask, and so we can both measure their oxygen consumption, so their energy, as you might do in a standard laboratory, or we can have them breathe hypoxic air to simulate altitude. So by having them breathe reduced oxygen, we can simulate a high altitude environment. So, decrease the temperature, we can increase the humidity, things like that, and create a simulated environment. In this lab, we also have the shooting system, the laser shooting system. And as you might expect, lots of physiological measurements occur in this. So core body temperature, heart rate, EEG, oxygen or blood oxygen levels, and things like that. So integrated measurement tools is really what we're looking for. We want everything, we want to measure all the important things as possible in the different environments. So some of these things we have integrated in the environmental chamber as well as in the Karen system. And some of this is outdoors as well, is electromyography, so muscle activity, electrocardiography or ECG, heart signals, EEG. We have both wet and dry mobile EEG systems, which can be taken outdoors. Heart rate, respiratory rate, eye tracking, which a lot of times is used for shooting as well as for vestibular therapy. Head and body posture and movement tracking, whether inertial measurement units or through the optical motion capture system. And so how does the Hexoskin webinar, what possible uses can we as the 5-4 lab or Warfighter Performance use the Hexoskin product line for? We're hoping to use them for a variety of things in the future as the development continues of the product. So the garment, as you know, is fitted. It's a fitted shirt for long-term use during activity, walking, running, and jumping. So we're hoping to take advantage of that in comparison to a heart rate monitor, which might be bulky, or the participant can go outside out of Bluetooth range, some of those applications. In particular, the Hexoskin Smart, we're trying at the moment to integrate it for real-time streaming of heart rate, breathing rate, accelerometer data of participants in the Karen. So as you can see a few examples down below, we'd like to know how their breathing rate, their heart rate changes in some of these different scenarios, and integrate that with custom VR programs and time syncing across multiple data sources. The benefit of the Astroskin is that it now has the oxygen, the SpO2, so the oxygen saturation and 3D ECG, which we are, again, hoping to use for validation purposes against products that we're developing. An example of our virtual reality in use and the development and integration that we're doing. Another product and one of the main uses that we're hoping to use the Astroskin for is in conjunction with a funded study through DITRA, the Defense Threat Reduction Agency, in collaboration with Arizona State University and Naval Surface Warfighter Center in Indian Head. And this is called the ear wearable device. It's a wearable device, as you can see, these participants goes in the ear, and this device is being developed to identify bio and chemical war hazards in the field through the monitoring of both a direct chemical sensor, but also through changes in heart rate, changes in SpO2, or blood oxygen saturation, changes in blood pressure, temperature, things like that. Everything, all those things could be measured with this ear wearable device. So currently, because that's in the development stage, we want to compare it to gold standard measurements. And we're in the process of integrating that or determining if we can use the Astroskin shirt to add that gold standard measurement for heart rate and blood oxygen level. As you can see, the participant in the left is wearing the Astroskin SpO2 sensor on his forehead. And through that validation, and again, a wearable shirt such as the Astroskin might be able to allow us to do that in one combined unit. That'll help us to develop this ear wearable device and deploy it in the field.